Hello and welcome to this mesh node test example. We're going to start off back in our code snippets. So if you just again open up modules, go to miscellaneous and go to code snippets. We're going to start off with our very first little code snippet, which was creating a series of controllers. So we were imagining we had a huge amount of rocks in our scene, or meteorites that we had to put controls on so that they could be jiggled, wiggled, moved around by animation. And what we didn't want to do was have to cycle through, God forbid, 1,000 rocks and put controls on them. But what we want to do now is just add in the functionality that we've just created for a mesh node, because we were parent constraining them. But as most pipelines probably would dictate or require, they probably should be skin clustered so that they can just be copied over. I mean, I've been in quite a few pipelines where they literally only want things to be skin clustered and plugged in a specific way. They don't like items being parent cluster or parent constrained. So let's imagine that we start off with, at the beginning of the script, parent constrain or skin cluster. So this could be in a function, and these are the arguments. So it could have a default, maybe of skin cluster, but you also have the option, if needed, to do parent constrain. But let's just leave it as is for the minute. So we cycle through. We still got the same code then below with passing through the group and the model group, because let's say that these are default items within your scene. You'll always know that you have, say, a model group that has then the children, which you need, but you maybe don't have a control group. Maybe you have to create that. So that could be something that you do. You just create in there, instead of saying control group, you actually create an empty group called control group, and then you pass that through to the DAG node. So that's also another option. But then we cycle through and we go for all the rocks. So everything within model group, we're going to save out, which would be a DAG node, but we're now actually going to change that and make that into a mesh node. So we're going to pass through I, which would be DAG, which will then transfer into a string because it will be requested by the mesh node, and then it will become a mesh node. So now we're cycling through and we've already got a little bit more functionality with every one of these rock items. Okay, great. So now let's move down to the next new piece of code. We've still got this main chunk of code here is still the same, but what we are going to do is essentially jump down, and we're going to, instead of just going ahead and constraining, we're going to say, well, if parent constraint, then constrain and scale constrain. That's fine. But if skin cluster, what we could say is, well, okay, let's create our joint, which we're going to make as a DAG node, which is going to be M joint, and we're going to name it rock joint with the iteration that we are currently on. And then we're going to go through and we're going to say, well, joint parent to control, just because at the minute we may as well. You can also give that control an offset. We could also say, actually, one thing we should do, probably go move to control, parent to control, and then we're going to go rock, hard weight to joint. Okay, so perfect. This is amazing. It does everything that we need it to, essentially, for a skin cluster setup. The next kind of iteration with joint would be for you to actually create a joint subclass, which would allow you to create that joint in the right position, in the right place, have it parented to, all in one line of code. And this would then be joint. And then you would be able to give it all the parameters that you need, essentially, for that joint before. But again, that'll be homework for you, and it is great. You can essentially, again, abstract a lot of complexity, because there's some things that you can't really do very easily in Maya, like get a hierarchy of all joints that are skinned to a spine. You can't easily kind of check which meshes are aligned to them unless you're doing a Maya command. So you could just, again, have joint dot meshes, which would give you all the meshes that are weighted to that item, which again would give you a lot of ease. So if you have a left eye joint, and that is a joint type, you could then say, okay, well, joint, well, what is actually attached to this eye? And then you could get all the eye meshes then very simply. So it gives you a little bit of ease for that. Okay, you can then get the next joint item in the hierarchy. You could get the whole joint hierarchy, and yeah, again, you get yourself a lot of ability. But yeah, here's our update, just for creating a series of controllers. Again, this is kind of creating everything that it can now just become its own function, okay, itself, and you could add that into maybe a common into some common script somewhere, or just have it in a rigging script of like auto rigging and just simple rigging kind of controls that allow you to automate certain tasks. But now let's scroll down. Okay, we've got setting our controllers to hidden in the scene, which again, staying the same. We have got our change color intensity, sorry, which again is again staying the same. We don't need to update. But we've also now, what I've added for you is a little bit of a blueprint slash what you can do with your script. So currently, this is what you can do, but I'm also going to give you some code of which you could look to update within our mesh node to give you, again, a bit more functionality. So let's say you need to update a mesh. You've just rigged a bipedal character, and that's been passed through to animation. They're already animating with it, but we've got a UV update and a mesh update now from modeling. So what you need to do then is just give all of your older items a suffix of old, go through them, which again, all of this could be automated. You don't even need to do this step, but go through, give them all the suffix of old. And then all you need to do is cycle through all of those meshes, add them to a list, make sure they're a mesh item. And then going through that list, what you will do is have the old mesh, and then you can create the new mesh, basing it on that it will have the name of old, checking that these items exist. You could also do a little check. So if new mesh exists, oh, sorry, actually not exists, then you could raise an error. Or you could just inform the user just by printing. Okay, I'm printing the issue just so that the user knows there are actually some new meshes in here. That would be very useful. And you can even do checks on here just to check the UVs are the same. The mesh points are all the same. You could do that again within your script. Go, well, if mesh is matching, and then pass through another mesh just to again scan it against and make sure that it's everything that you can check for, like UVs, mesh points, are all matching. And if they are matching, well, there's maybe no point in updating this and running the next part of this script. It'll maybe save you a little bit of time and allow you to maybe check back with modeling if they've accidentally passed you through the wrong scene where the items that you're meant to be updating are not right. But let's have a look through our next section. So if mesh skin cluster, then you can copy that skin cluster straight to our new mesh. Let's do that. Great. So that's all sorted, done for us. Now, some of the new sections, which we haven't done, but you can feel free to add. You could go through and say, well, if there's any lattices or deformers or any other items that are added on, then mesh, add deformers to new mesh. So we're checking the properties, and then we're using the functionality to update our mesh. So we can then say mesh, well, if there are blend shapes, okay, let's update these blend shapes. Okay, that blend shape hierarchy should still plug in. Otherwise, you're going to have to re-go through all of that hierarchy, update all of those blend shapes, which again, could be another part of the script. So you could say, well, if mesh is the same, you could check that, and you say that as a variable. So if the mesh is the same, then reconnect all blend shapes. If not, then you can get if mesh is not, and then get the mesh hierarchy from this blend shape, and then update all of those blend shapes and replug them in the same order. Again, it sounds complex, but once you start going through it, it then becomes quite easy because you've got all of that hierarchy stored. You can have mesh blend shapes, mesh blend shape hierarchy. You could start adding all these features that add, again, and abstract all of this complexity. And then materials, just because, again, you might as well add the materials if they're going to be useful for the animators while in the scene. Again, mesh, copy materials. You may as well just add the materials across to the new mesh. But again, that is only if there are materials there. And you may set Lambert 1 as being a default material, which you don't register or you don't kind of look for. But if there are new materials on it, you can add that over. So again, you're seeing quite a lot of work here, because imagine you having to go through 20 meshes within a rig, update all of those one by one, copying the weights over. It's going to take quite a lot of time, copying all the, going through the hierarchy, checking all the blend shapes. All of this can take a huge amount of time, where if you already have an animation scene open in another window, you can update your rig, you can update the rig in that animation scene, check everything in the animation scene. If everything runs perfectly, then hey, you've just saved yourself 4 or 5 hours of work. Thank you so much. I don't, like you said, be smart. Okay, don't work hard, work smart. Okay, like I do work hard, sorry. But, don't work harder than you need to. There are so many ways of doing things, but I would always suggest you try and look for the smartest way first. Don't just jump into a task with both feet. Maybe, have a look at it, analyze what the requirements are, as we've said in the past, and then have a look at what the possible solutions are that are going to be the most efficient and the most productive for you in the future. Okay, and that is why code is generally the best way for this, because even if it takes you an extra 20-30 minutes now, or maybe even a day now to write this script, you could what you could do is save yourself hours days, months in the future on all of these tasks that are coming through to you. And that is from one line of, what is this? Maybe 30 lines of code here, mostly, okay, white space, but okay, it doesn't matter. But if that is, again, all of that time saved for you, what is that time that you could be doing? Running more scripts to update yourself, to make better deformers, make better hierarchies, make better systems for you to work with. So focus on that. Don't focus on the grunt work, on the hard stuff, okay? Focus on the smart stuff. Okay, thanks so much, guys. Take care, and I will speak to you in the next tutorial.